Okay, welcome to our second lesson in this unit on quadrilaterals. This lesson is on the properties of parallelograms, so we begin with this slide on what a parallelogram actually looks like. Now what you're going to want to do on this slide and the next slide is pause the video and be able to copy down notes from these two slides. So when you've finished copying this down, advance to the next slide by hitting play, and then you'll want to pause on that slide as well. Okay, now that you should be back. What we have first is parallelogram CDEF. We're told that DE is 76 millimeters, DG is 33 millimeters, and the measure of angle FCD is 48 degrees. We're being asked to find CF. So using our rules, what we should first notice is that CF should be congruent to DE. Now that is by our theorem 6.2, which says that parallelograms imply that opposite sides are congruent. So using the definition of congruent segments, we would say that CF and DE have to be equal in length. And since we already know that DE is 76 millimeters, we would just plug that in for DE, and that would tell us that CF was actually equal to 76 millimeters through our substitution property. Okay, using the same information, this time we're asked to find the measure of DF. DF is a diagonal. So in the diagonal here, remember one of our rules is that the diagonals have to bisect each other. So what we can now say is that DF is actually equal to 2 of DG, because DF got split into two equal parts, DG and GF. They have the same length, so it's as if GF is just another DG. So since DF equals 2 DG, and we already know from the given information that DG is 33 millimeters, we'll be able to plug in. So we have DF is equal to 2 times 33. That's just substituting 33 for the DG. So DF is equal to 66, and all of this was made possible by the fact that in a parallelogram the diagonals bisect each other. That's our theorem 6.5. So they will always split each diagonal into two equal parts. Last but not least, we're asked to find the measure of angle EFC, which in this picture, for this parallelogram, is the entire lower right angle. So what we know about the angles in our parallelogram, specifically because we were given in the given information FCD is 48 degrees, which is the lower left angle, is that our consecutive angles have to be supplementary. So angle EFC, its measure plus the measure of angle FCD, has to add up to 180 degrees, and that's because parallelograms imply that consecutive angles are supplementary. That's our theorem 6.4. So using that, we'll plug in the FCD being 48 degrees, and that will allow us to solve for the measure of angle EFC. So here we have the measure of angle EFC plus 48 equals 180. That's just by substitution. So the final step to solve for the measure of angle EFC would be to subtract 48 from both sides, leaving us 132 degrees for the measure of EFC. So now we know the measure of that angle. If at any time during this presentation you need extra time, please just feel free to pause the video to look at the slide closer. Here we have another parallelogram, WXYZ, and the first time we're asked to find YZ. So what we should notice about YZ is that it represents the length of a side. In this case, that length is 8a minus 4. Now what we know about parallelograms is that opposite sides are congruent. So we would start with the fact that YZ is congruent to XW. And you can see that that's been marked in the picture. So that means that the lengths of those two segments have to be equal. So we'll be able to set the 6a plus 10 and the 8a minus 4 equal to each other and solve for a to ultimately find the length of YZ. So the fact that those two segments are congruent, because we know that in a parallelogram opposite sides are congruent, again theorem 6.2, Then allows us to use the definition of congruent segments to say their lengths have to be equal, which then allows us to use the substitution property to make the statement that 8a minus 4 has to be equal to 6a plus 10. Now we use simple algebra. Subtract 6a from both sides to have 2a on the left, add 4 to both sides to have 14 on the right, and that's going to give us 2a equals 14. Now in the final step, divide by 2, the final step of finding a, that is, and we get that a is equal to 7. Now we were asked to find the measure of yz, which is represented by 8a minus 4. So we need to plug that 7 back in to 8a minus 4. So what we get is 8 times 7, or 56, minus 4 equals 52. So we know that yz has a length of 52. Using again the same information, now we're asked a question about one of the angles, the measure of angle z. Well, what we notice is that we're given two angles. One is the measure of angle w, the other is the measure of angle z, and those would be considered consecutive angles. So we can use our rule for consecutive angles in a parallelogram to state that those two angles must add up to 180 degrees. Again, that's theorem 6.4, that consecutive angles in a parallelogram are supplementary. So what we do now is use that information, plug in the values that they gave us for those angles. Those would be the values involving the variable b. So we can say that 9b plus 2 plus 18b minus 11 equals 180. That's just by substitution. And now what we do is combine our like terms. We put the 9b and the 18b together by addition, giving us 27b, and the positive 2 and the negative 11 together by addition, giving us negative 9. So we end up with 27b minus 9 equals 180. And that was just by combining our like terms. Now just do a little bit of simple algebra, add 9 to both sides to get 27b equals 189, and then divide by 27 to get that b equals 7. Now that we know what b is, we'll want to take that value and plug it back into the measure of angle z, which is represented by 9b plus 2. So we want to take 9 times 7, or 63, plus 2 equals 65, which tells us the measure of angle z is 65 degrees. Now what I want to leave you with here is two questions about this picture. I want you to take a moment and pause the video and work through finding out both the measure of segment TQ and the measure of angle T. Now you'll have to do some work to find both the variables x and y in order to make this possible. And then I want you to come back and check yourself, because I will provide the answers to these two, but you need to work through them first. So please pause the video now so that you have a chance to work through it. Okay, we're back. Now in order to solve for TQ, TQ is a side, and we know that one of our rules says that in a parallelogram, opposite sides are congruent, and that's theorem 6.2. So we'll take TQ and set it equal to RS, those lengths, so the TY plus 12 and the 4Y minus 4. We would solve for Y in that case, and then plug back in to the 2Y plus 12, and that would give us a length for TQ of 28. Now, for solving for the measure of angle T, what we have to use here is the fact that opposite angles in a parallelogram are congruent. Now, the rule that tells us that is theorem 6.3. Opposite angles in a parallelogram are congruent by theorem 6.3, and the opposite angles here are angles Q and angle S. So those are the two angles involving the variable x. I would set those equal to each other. Now the trick here in this problem is once you find x and you plug it back into one of those angles, it doesn't matter which one you plug it into, both of those angles are supplementary to angle T, the angle that you actually care about. So once you plug back in and find out what either Q or S is actually equal to, that's not where you're done. You need to then take that value and subtract from 180 to get the measure of angle T. which is 71 degrees. Thank you for watching this lesson. Good luck and have a great day.